Welcome to my channel. Today we are going to discuss about graph data structure. Now what is a graph actually? Graph is a collection of nodes and vertices connected by the edges. Now nodes are also called as vertices and edges is also called as links or lines. Okay, now there are some real-time applications of graphs, so we can use the graphs in a social media and to follow the networks and all, and GPS, Google Maps to find out the shortest path, and search engines, page ranking and all that we can use, and networking also, routing protocols also we can use. Okay, now these are the real-time applications. Now this is the graph representation that you can easily identify. There are some nodes 5, 3, 1, 2, 4, and 6. So these are the nodes represented with a circle, and there is some lines, right? This is called as the edges. Okay, this is called as the edges. So this is this edge is actually used to connect the two nodes. Okay, now you can see the different edges that you connect all the nodes of the graph. Now this is the general representation of the. Now you can see the different types of graphs in a data structure. First of all, null graph. Okay, null graph is also known as graph if there are no edges in the graph. Now you can see this diagram. All the nodes are, there are four nodes, but the nodes are not connected, right? This is called null graph. The nodes are not exactly connected, so it's called null. Now trivial graph. Graph is having only a single vertex, that is called as a trivial graph. Okay, now undirected graph, a graph in which each edge do not have any direction. Undirected, there is no direction between the nodes. Simply 5 and 3 are connected, 3 and 4, 1 is connected 1 to 4 and 4 to 5, but you can move from anywhere. This the meaning of this edge is we can move from 1 to 3 or 3 to 1, 1 to 4 or 4 to 1. So this is called actually undirected graph. Coming to the next one is directed graph. So the directed graph in which edge has a direction. Okay, the direction, you can see the arrow symbol, the direction from 5 to 3, but there is no direction from 3 to 5, right? Now coming to, there is a direction from 4 to 1, but there is no direction from 1 to 4, right? So this is called actually directed graph. It will show the directions to move from that node to next node. It shows the arrow representation. Now coming to the next one is connected graph. Connected graph, a graph in which from one node we can visit any other node in the graph is called as a connected graph. For example, if I visit 5, I can visit 1, right? I can also visit 1 from 5, because all the nodes are connected, like from 5 to 3, 3 to 1, and 1 to 4, 4 to 5, anywhere, right? So all the nodes are connected, so that it is called as a connected graph. Next one is disconnected graph. So disconnected graph, which at least one node is not reachable from any node or any other vertex. It is also called as in disconnected graph. So now we can see 5 3 4 1. 5 3 is connected and 4 1 is connected, but the complete graph is not exactly connected, right? So that it is called as a disconnected graph. Okay, now coming to the next one is regular graph. Regular graph in which the vertex of each vertex is equivalent to k. Mean k is called as a regular graph, k regular graph. Now you can see the degree of each vertex. Degree means the number of edges connected to that particular node, that is called degree. Okay, 5, how many edges are connected to 5? 2, right? Now how many nodes are connected to 3? How many edges are connected for 3? 2. And how many edges are connected to 1? 2. And how many edges are connected to 4? Is 2. So this is 2 regular graph, because the equally all the nodes are connected, so that it is called as a 2 regular graph, where 2 is a k number of nodes are connected, right? So now coming to the next one is complete graph, a graph in which from each node there is an edge. So now, cycle graph. Graph in which a graph is a cycle in itself. The minimum value of degree of each vertex is 2. It means all the nodes are connected in a cyclic form. Okay, 3 to 1, 1 to 4, and 4 to 5, and 5 to 3 again. Okay, the vertex of each node is actually 2, right? You can see what is the degree of 5? 2. What is the degree of 3? 2. So means all the nodes are connected in a circular manner. Okay, now coming to cyclic graph. Cyclic graph is different and cyclic graph is different. Cyclic graph containing at least one cycle is known as a cyclic graph. Okay, at least one cycle in the overall graph. You can see there are 4 nodes, but in the subgraph is actually cycle. You can say 3 1 4 is a subgraph, okay, which forms a cycle. This is called cyclic graph. Cycle is different and cyclic is different. Cyclic means it contains at least minimum one cycle. Okay, now bipartite graph. Bipartite graph in which vertex can be divided into two sets such that the vertex in each set does not contain any edge between them. Okay, such that each set does not contain any edge between them. Now you can see, so this all the node, this is the one set and this is another set. It is actually bipartite. It is actually divided into two partitions. Okay, so now this is the one type of graph. All the nodes are connected. Okay, so v1, v2, v3, v4, v5, and similarly here also all the nodes are connected. Now directed acyclic graph, directed graph that does not contain any cycle. Now you can see the graph does not contain any cycle. Okay, so you can see the directions first of all. So from 5 to 3, but there is no direction from 5 to 4, right? Okay, but you can't move here. And let's assume 3 to 1, and there is no direction from 1 to 4, and it is not exactly a cycle, so that it is called as a directed acyclic graph. Okay, now coming to the weighted graph, a graph in which the edges are already specified with some suitable weight. So each edge is having a specified with some weight, that is called weighted graph. Okay, 1 to 5 is 1 and 5 to 0 is 10. Okay, and 0 to 2, these are the nodes distance, weightage is 3. Okay, this is called if the every edge is having some weight, that is called as a weighted graph. Next, there are some basic properties of a graph, vertices, characteristics or properties of a graph. The main important properties is vertex. Okay, without a vertex, we can't use the graph, right? So vertex is actually represent the physical object, right, concept or abstract entity. Now edges, so in between the vertex edge must be there, right, to connect the directions, either it may be directional or in unidirectional or bidirectional. Weight can be assigned to an edge representing the cost or distance between the vertices. Okay, now degree is nothing but the number of nodes which are connected to that node. Okay, path, and there is, if there is a link between, if there is an edge between the node, that is called as a path. Okay, cycle. Okay, just if simple cycle does not contain any repeated vertices or edges. Okay, the cycle path starts and ends at the same vertex, right? So starts and ends at the same vertex, so that is called as cycle. And the connectedness, under the whether the graph is connected or not, we have to know the connectedness. So these are the main properties of graph or properties. Okay, properties or characteristics. Now the graph can be represented in a two way, that is, one is adjacency matrix, other one is adjacency list. Now coming to the adjacency matrix, so it is actually a matrix form. Each entry in the matrix represents some weightages of each edge. Okay, now let's consider this is the graph which contains 4 nodes, and this is undirected graph anyway. So now let's see 4 nodes, so that we need to take a 4 by 4 matrix. Okay, the number of rows and columns are 0 1 2 3 and 0 1 2 3. If the, now you need to identify if there is an edge between them, that will be represented with 1. If there is no any edge between them, between the nodes, that is represented by 0. 0 to 0, there is no edge, right? So that's 0. Okay, 0 to 1. There is an edge, right? 0 to 1. Yes, it represented with 1. 0 to 2. There is an edge, right? It is also 1. 0 to 3. Is there any edge? No, it will be 0. Now similarly from the node 1 also you need to identify. 1 to 0, is there any edge? Yes. 1 to 0 is edge, so 1. 1 to 1 is there any edge between from 1 to 1? No, so that it will be 0. Now 1 to 2, yes, 1. And 1 to 3, no, so that 0. Similarly, you have to represent with all the nodes. This is called as the adjacency matrix. Now, adjacency list. The graph represented with the linked list. It is a collection of a linked list. There is a pointer which is actually pointing to the next node. Okay. So now 0. Okay, 0 is actually connected with 1 and 2, right? 0 is connected with 1 and 2. So that is represented with the link 0, 1 and 2. Now come 1, 2. How many nodes are connected? 1 to 0 and 1 to 2. So 1 to 0 and 1 to 2. Right. Next, coming to the next one, uh, from 2, there is 2, from 2 to 0, there is a direction from 2 to 0, and next 2 to 1, next 2 to 3 also there, right? Now coming to the 3, how many nodes are connected from 3? Only 2. From 3 to 2 only there is a direction, there is a path, or there is an edge. From 3 to 2 there is no, 3 to 0 is not there, 3 to 1 is not there. So likewise, you need to represent the adjacency list by using a linked list. Thank you.